One of the constants that we saw during that presentation, at the beginning of the presentation, is time. And we all have time, right? I mean, we all have time to waste. Hell no. Time means money. So what we're trying to do here is create the quickest response, the fastest response, while maintaining safety and efficiency. That is the important thing for us. So how do we do that? How do we do that? Because again, some of the stuff that you see on the screen, you have seen before. But let's put this in a context that makes more sense to us. Sons and conduits, secure remote connectivity, deep OT visibility, role-based access controls, SOC and NOC, and advanced threat protection, or advanced persistent threat. That is something that we need to look at. In reality, to defend all this and to translate security, efficiency, and resiliency into terms that can be controlled, that can be reduced in time, we need to work on those four little boxes in the middle. In fact, let's do the first three. Let's forget about the last one on the right. The first thing is visibility. We need to have visibility of traffic. We need to have visibility of devices. We need to have visibility of all these cool devices that we have that affect the power plant. Detection, identification. And I know, in new terms, IIoT and IoT, that is really important. But when you think about it, if you can see it, you can protect it. That's where it starts, with visibility. And we're going to make a little bit of a distinction between visibility and visualization, because the term visualization, for us, visibility, or for most people, visibility is being able to see the traffic. Some other people think of a topology map, and I think that they're both, valid definitions. But the reality is, when we're talking visibility, the way I like it is, you have Google Maps, and you have your windshield. If you have visibility, you know that you can turn left and right. You see the threat, you see what's going on. Google Maps is great, right? You have visualization. It gives you a really cool map as to where to go. Will you trust it to drive your car without your intervention? I guess it depends. If you have a Tesla and you bought the $12,000, autopilot, maybe you do, I don't know. But the reality is that we need to have visibility to make those decisions. And to follow up on what Chris said, that man in the middle. We need to have that visibility to make accurate decisions. If we can see it, meaning, and now we're talking in cybersecurity terms, if we can see it, we can control it. Control, the four basic functions of any cybersecurity system. We monitor, we block, we allow, or we quarantine. That's that. Every cybersecurity system can be boiled down to those four basic concepts. That's what we do. But monitor is really important, because monitor is going to take us to the next one, intelligence. And if you like me, I've been around the security field for quite some time, you know that there are so many freaking sources of data. And to Chris's comment, I always say that, right? People that work in SOCs and NOCs and whatever the operation, security operation you have in your industry is called, they can get jaded. Because really, the volume of alarms, if they're not properly correlated and assigned some level of intelligence, it's like I say, I'm ignorant and apathetic, I don't know and I don't care. So the same thing will happen there. So bringing some intelligence, some degree of correlation that we can get those sources of data and create something that makes sense to the business and reduce the risk, that's really important. That will lead us to automated response. And in that part about automated response, that in our business, that sometimes that's like a four-letter word. How much automation, automated reaction do we have of a particular condition using IT systems? Because ultimately, even if they're OT, they started in IT. That's where everything started. So those systems, how much do we allow them to respond automatically? To do that, we need data fidelity. We need to have our processes properly mapped. Like Chris said, creating proper templates. And again, you cannot automate a process that you have not properly mapped. There's companies that spend millions of dollars automating something that they don't even know they have or they don't need. So that is foundational. And the last thing is advanced threat protection. I think it's backwards. But using deception technologies and leveraging artificial intelligence. And again, when we're looking at the maturity of companies or the maturity of our processes, we might be in a position as a business that we allow, decisions to be made by artificial intelligence. We might include some deception technologies, but this is all contingent on how much risk it brings to the business. What is your risk tolerance? in order to see things, these are some of the protocols that we deal with all the time. And to be brutally honest, yeah, you probably identify one or two, like myself. I've been doing this for 36 years. So you might see protocols like Modbus and all that, but what does that mean in terms of, let me get out of your way here so you can get a picture and we can share this with you guys at a later time. But what does this mean, having visibility of all these protocols and applications and all that? Because this is foundational in terms of having visibility inside of the packet and making those decisions. What does that look like for us? If we do deep packet inspection on a Modbus string, we're looking at categories like what happens if I see that string of 01010101 and then 00A? What does that mean? In the past, there were some CVEs that will take a PLC and will send it back to factory default. Well, if you have that in your environment and you know that is happening, now you have the power because you have the visibility to whitelist your traffic and say, when I see the 0101010100A, then I can say, not only no, but hell no, you're not going across. So ultimately, what you have done, if you whitelist it, and this can be done at a larger, I'm not gonna say massive scale because that's kind of scary, but at a larger scale, that you can bring it down to only the traffic that needs to be on your network, that's the traffic that you allow. And we can do that because all of us are looking at, we have some of those bad boys in our environment. So we can get to this point that we only allow what needs to be allowed. So here we go about visibility, because this is a graphical representation of a network. And it's important to us because, yeah, we are visual people. I know, I'm a mathematician by profession, and I like numbers. I love my numbers, but there's a lot of people that prefer something of this nature. So that visibility can also be visualized. And that level of visualizations will allow us to make decisions based on that, because then you can go into the three typical conditions, right? That we see in a map of this nature. Green is good, yellow is maybe, red is bad. There's some people that define that, that work on those terms. And honestly, when you look at your sock and knock and you get that first line of defense, that might be a human that is looking at a gigantic screen. Maybe when they get to yellow and red, you want them to jump. So we want to not only have the visibility at the engineering level, because let's call a spade a spade. When you start looking at registering what goes across, you're making decisions, that are engineering related, because you have to engineer traffic. It's traffic management. But that has a lot of value as well. In addition to that, if we start looking at the traffic and doing deep packet inspection, it will behoove us to have, oops, did it go back? Oh, all right. Jumping back and forth. Indicators of compromise. So for us, yeah, we can whitelist a network till we're blue in the face, but let's leverage the intelligence that we get from our providers. This is really important because it keeps going back and forth for some reason. But let's go back to the indicators of compromise. All right, if it jumps one more time, I want to skip it. This is starting to become annoying. Anyway, like the guy that invented the cereal, thanks for nothing. So when we're looking at the indicators of compromise, that can lead us to automation as well. So that's what we're looking at. And at the end, the question that we'll have to answer here is how much automated response are we going to have at the end of the day? Myself, I say that we're in a transition period where we are embracing automated response and less human intervention. I think as those of us that have been doing this for quite some time, we lead the business, it's going to be inversely proportional. The less of us that are around, there's going to be more automation. And we can go into an entirely different beer discussion as to what is it that, the expertise is living the field, and we need more people to embrace the technology and get in this one. So anyway, some things for visibility. When we start structuring our network, structuring our environments, these are some of the models, that we follow, architecture models that we recommend for visibility concerns. IEC 6243 and the Purdue model that will give you a good tiering of your environment. Is this gospel? No, it's not. This is the North Star. You might not need all these levels of division. However, it's good to know that if we need to isolate a particular threat, again, microsegmentation, and we talk about that as well, when we start reducing our collision domains into some manageable chunks, we look at microsegmentation as a proactive approach to mitigating threats. So that's one of the things that this allows us to do, because at this point we see it in a vertical way, right? And we get it from the plant all the way up, and we can segment at that level. We can segment at level 2, layer 2 OSI, that's one thing that we do. But if we go back a couple of slides and we go look at that Modbus breakdown, now we're looking at layer 7 OSI, which will allow you to do microsegmentation based on application. And that's a really powerful tool. Because for all of us that have an engineering mind, that means that I can create segmentation based on whatever comes or define it by software, or as they call, software defined, right? What does this segmentation look like? This is just an example. Please don't go out if you don't have this on your environment, run out and say, oh crap, I mean, we got to hire people. But in the end, when we start correlating automation, we start correlating defense in depth and visibility, we have to look at all those conduits. We need, look at high availability. We need to look at all those concepts that will take us to not only defense in depth, but resiliency and reliability. I skip on that one because I like to talk about automatic microsegmentation. And let's forget about brands and forget about everything. Let's talk about conceptually what this means. When we talk microsegmentation, a lot of us, they take 2 steps back and say, man, that's a lot of work. I always say, give it to the laziest guy in the room and he'll figure out how to make it easy. When we start looking at this and we start looking at technologies like network access control, and we do device identification at layer 2 OSI, the moment that there is a link state change on the device, then we can say, oh crap, there is a Siemens PLC. I recognize it as a Siemens PLC. I'm going to move into my VLAN 300, and upstream on the firewall, regardless of your vendor, you have a policy, you have a security treatment that will say whatever comes on that device on VLAN 300, I'm going to allow, I'm going to decline, I'm going to deny, I'm going to quarantine, I'm going to monitor. So you have that device, plug it into your network. It will put it in the proper VLAN. It will apply a security treatment, and you effectively have segmented your network from layer 2 to layer 7 with very little touch. So what does that mean in common terms, right? What does that mean to us? Is going back to that point that we want to reduce our collision domains, so we have as a proactive approach to response. So that's one thing that we're doing. And of course, this example is really rudimentary when we look at it. 100, put a Siemens, a Schneider go to 200, the 100 ABVs, go to 100, and then you got one that Click PLC. So Click PLC, we don't know what it is. It's not allowed by our business. It's not one of the ones that pass change control and all the mechanisms that we have to allow things in our network, and we isolate that guy. Notice that I say isolate, I didn't say block it. Going back to the discussion before in the levels of readiness, maybe we need a human to ratify that thing either needs to be there or doesn't. So the decision is ultimately yours. It's made by a human. Do we have a great appetite for automation? Again, that goes with the risk to the business and is determined by you guys, by the business rules.